infinite series. So a series that goes on forever. And the main question is, can we add an infinite number of positive numbers and not get infinity? So an infinite set of numbers, none of them zero, like that'd be cheating, right? You could add up an infinite number of zeros and not get infinity. But I want to add up an infinite number of positive numbers and not get infinity. So some of you are like, I don't think so. Shaking your head no. And I get that. Let's paint a wall. Not literally, I don't have the paint. But let's paint a wall. And here's how we're going to do this. Each day we'll paint half of what's left. It's going to take a while to paint this wall. All right, we start out fired up. We paint half the wall on day one. In fact, let's draw some pictures here. So at the end of day one, we painted half the wall. Why don't we just paint the whole wall? I don't know. It's a math problem, so work with me here. And we're going to keep track with how much we painted that day and the total that's been painted. Well, on day one, that's kind of an easy pick because we painted half the wall, and half the wall has now been painted. All right, day two. We wake up, we admire our handiwork, and say, you know what, I'm feeling a little bit lazier today. Rather than painting the other half of the wall, I'm only going to paint half of what's left. So how much of the wall did we paint that day? 1/4. And how much of the total wall is now painted? Yep. So we go to bed, go to sleep, wake up the next day. There's our 3/4 of the wall painted. Feeling really lazy today. Let's only paint half of what's left. So how much of the wall did we paint that day? 1/8. How much of the total wall is now painted? 7/8, because there's 1/8 that's not painted. Let's do this one more time. So on day 4, again we paint half of what's left. So that's 1/16 of what we painted that day. How much of the total wall is painted? 15/16. Okay, now for the tricky question. Is this wall ever going to be done? Yes, you're kind of right to hedge. Like mathematically speaking, no. right? But after like 30 days, like then you're getting like a toothpick out to dot the wall. It's kind of ridiculous. So yeah, as n gets really, really big, as n goes to infinity, I mean, and it doesn't even have to get really that big, right? Like after a month, we're pretty much painting. How much of the wall would we be painting after 6 months? Roughly, how much of the wall would we? Okay, so pretty much the whole wall would be done, and we wouldn't be painting any that day. If we ever got to infinity. Of course, that's the trick. Like you never get to infinity. So that's kind of the trick for today is we added up. Here's what we did. We did 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32. If we could do that forever, that would be the whole wall. So we kind of just answered our first question. Can you add up an infinite set of numbers, positive numbers even, and not get infinity? And the answer is yes. It's a little bit weird. Because we got to 1.
So is it only fractions that?
Okay, so there's some rules here. So careful with only fractions. You're on the right track. So what would make it so that it would converge? That's the fancy word, as opposed to diverge. What do you think the terms have to be doing in order for this to work? Okay, they're definitely all going to be adding. What about if we did it this way? 2 plus 4 plus 8 plus 16. What's that going to equal? Not 1. We would say that diverges. That's not headed toward anything. That's just getting bigger and bigger. So there is something about the numbers that matters whether this is going to work or not. And that becomes a big deal for the formula. So you mentioned fractions. What if we did 1/3 plus 1/3 plus 1/3? Is that going to converge to one number, or is that also just going to blow up? That's getting bigger and bigger. Not bigger a lot, but bigger. It never goes to one number.
So it needs to get like smaller.
You need the terms to get smaller. And it doesn't really even matter how big they start. If you started at 100 and you cut it in half every time, that's going to be some big number, but it is going to converge. That is going to work. So there is definitely something going on about when it works and when it doesn't work. And the smaller thing, that's probably the key here. The absolute value of r must be less than 1. So you need the terms to get smaller. Absolute value, because they could change signs and that would be okay. But you need them to get smaller. All right, here's the formula. The formula is actually easy. It's kind of weird that it's the easiest formula we have for the most sort of complex concept thing going on. For an infinite geometric series, the sum is equal to a1 over 1 minus r. If this comes with a major if, if the absolute value of r is less than 1, meaning if your terms are getting smaller. The trick is, if your terms are not getting smaller, you can still use the formula and you'll get an answer, it just won't be right. So you have to know, like some formulas, if they don't apply, you use them and you get a funny answer and you're like, this isn't right, this doesn't make sense. This one doesn't work that way. If you plug in an r that's not supposed to work, you'll get an answer and you might not realize that it's not the right answer. So you've got to be careful about making sure it's a formula or it's a series that converges. Let's do some examples. Find the sum from n equals 4 to infinity, 64 times 1/2 to the n. So if we want to use our formula, we have to know if that's geometric and if r is less than 1. And probably the easiest way to do that is to list out the first few terms. Because maybe you could tell by looking what r is, but maybe not. So let's see, if n is 4, 64 times 1/2 to the 4th. Let's see, 2 to the 4th is 16. 64 over 16 is 4. N is 5. 64 times 1/2 to the 5th. 2 to the 5th is 32. 64 over 32 is 2. And maybe, hopefully, some of you realize right now, can you tell what r is? I mean, you might have been able to tell from the equation. But if not, you can tell now, it's times 1/2. So 1/2 is less than 1, so we are eligible to use our formula. So A1 is A1 over 1 minus r. A1 is 4 over 1 minus 1/2. 1 minus 1/2 is 1/2. 4 divided by 1/2. 4 times 2 is 8. So this is kind of weird that you could add up an infinite number of numbers and just get some regular number. It also makes it really hard to check, because the only way you could check to see if 8 is right, how many numbers would you have to add in the calculator before you got to 8?
Probably a lot.
All of them. Now you could get close, and you could get close enough to know you're getting it right. 4 plus 2 plus 1 plus 0.5 plus 0.25 plus 1/8. That's not all of them, but I'm getting close to 8.
Oh, okay.
So there's no way to check the answer. And I mean, you can kind of check it, but you can't check it for sure. Let's find the sum from n equals 3 to infinity of 1/2 times 4 to the n minus 3. Is that geometric? And if so, what is r? Or do we need to find some terms to figure it out? Okay, so if you're done enough of these, you recognize that r is 4. If r is 4, what does that mean for our equation? It diverges. It's not going to work. So there is no answer to this. It diverges. You're done.
That's the answer?
That's the answer, because there is no sum. If you didn't know that r was 4, well, you'd have to plug in some values and see what happens. So if I plugged in 3, I'd get 1/2. If I plugged in 4, I get 2. Plugged in 5, 16 over 2 is 8. And then hopefully you'd realize, wait a minute, these terms are just getting bigger and bigger. So my formula doesn't work if the terms are getting bigger. They've got to converge, not diverge. So your answer to that problem is diverges. There is no sum because it's just getting bigger and bigger. Example 3, 81 minus 54 plus 36 minus 24 plus 16. Are my terms getting smaller? Yeah, so this should work. I just need to figure out what R is. So how do I figure out what R is? How do I figure out what we multiply by? So R is always any term divided by the last term. So pick any term you like and divide it by the previous term. So we could do negative 54 over 81, but it might be easier to come out here and do something that's easier to reduce. We're multiplying by negative 2/3 each time. So are we eligible to use the formula? Yeah, terms are getting smaller. So the sum is the first term, 81, over 1 minus negative 2/3. Uh-oh, we have to be careful here. 1 minus 2/3, or excuse me, 1 minus negative 2/3 would be 1 plus 2/3, which would be 5/3. And 81 divided by 5/3 is the same thing as 81 times 3/5. Keep it, change it, flip it. Again, no calculator on this test. Some of you, this is going to be the hardest part, is doing this little math stuff by hand. One more. An infinite geometric series has A1 equal to 9 and sum equals 15. Find R. Infinite geometric series has A1 equals 9, the sum equals 15. Find R. So we'll use our formula. And I just plug in the things that we know. The sum is 15. Oops, A1 is 9. 1 minus R. Okay, algebra experts, what would you like to do to solve for R? I wouldn't divide by 9 because then you got 1 minus R stuck in the denominator. I'd multiply by 1 minus R. So I got 15 minus 15R equals 9. So negative 15R equals negative 6. And negative 6 over negative 15 reduces by 3 to 2/5. That one really wasn't. That was just an algebra problem more than anything. Again, that formula not given on the test, except sort of given because it's a multiple choice question. So as long as you can recognize it and spot it and pick it, then you'll be good to use it the rest of the way.
Pretty much all of them are given, right? All of the formulas.
So I will give you the two sum formulas.
Yeah.
I'm not going to give you the sort of the term formulas. But most of the time you can kind of figure those out, and you sometimes don't even need those. And then the one we did today, I'm not giving it, but if you can pick it out of a multiple choice lineup, then you'll have it.
When you say it's a multiple choice, do you mean like the question is which of these formulas says?
Yeah, it's like, which is the infinite sum formula? And obviously, there's our correct choice. I don't remember what the wrong choices are, but I bet r minus 1, that'd be an easy thing to mess up.
Plus 1.
Yep, you could go 1 plus r. Maybe switch it around, make it 1 minus r over a1. So, is that confusing? I hope not. Hopefully you look at that and you're like, yeah, I remember it's this one, and then you've got it the rest of the test. So that's what I mean by, is it given? No, but if you can recognize it, you'll have it. All right, tomorrow we will have time to work a few questions from worksheet 4, or any worksheets really, but worksheet 4 especially, since that's what we just did today. And because it's like the math isn't hard, but the concept is a little bit crazy, that we're going to add up an infinite number of non-zero numbers and not get infinity.